And achieving competitive advantage over the years have proven not to be just through mergers and acquisition, but really allowing companies to focus on organic growth. And in the ability to grow organically requires organizations to focus very closely on the data that they've gotten over the years and what kind of information, what kind of decisions can be derived from that data. So companies are in all earnest moving very rapidly towards leveraging data in a very powerful way so that they can be in a position to make the right decisions at a much more effective and much faster rate than competitors. And given the reduction in margins, depending on the industry that you're in, information is really a critical component in a company's ability to derive marginal advantages over competitors. So today I wanted to focus on driving competitive advantage with customer analytics. So the first slide really speaks to the typical environment that exists within most organizations delivering business intelligence and reporting solutions. It usually starts with, a number of systems of record, what we typically refer to as legacy systems, either old mainframe systems, IBM-based mainframe systems that captures low-level granularity transactions, be it in the bank where you actually withdraw money from an ATM or you go to the branch and actually transact over the counter. Those traditional source systems still remain and are critical from an operational perspective. They are the entry points to the creation of data for most organizations. But they're really good at that only, which is to capture the event, capture the transaction, document it, store it, and move on to the next transaction. Not necessarily helpful to a senior executive who has responsibility for actually driving the strategic vision, looking at the organization's competitive position and how they can drive growth. Those transactional source systems don't necessarily provide that executive much information in order for him to be able to make the right decisions with respect to the strategic vision of his or her organization. So source systems are great, they're critical, they're required, but a transformation needs to occur, and that transformation usually begins in moving that millions of rows of transactions that have been stored over the years in those source systems into what was recently more popularly known as the data warehouse, which is a huge repository that is structured in such a way that the granular data can begin the process of transforming itself into what is referred to as information. That data warehouse is also referred to as an operational data store. Some of you may have heard that term. Another name used is an enterprise data warehouse. And another name used is typically referred to as an integrated data repository. So the name doesn't necessarily matter, but what matters is the transformation process that begins within that repository, where you begin to capture all the transactional events and understand the data points and link the data points in such a way that you're beginning to shape the information that this executive who sits in the C-suite is really looking for. So that data warehouse, as we refer to it, is the process that begins the transformation. Typically, it stores data in the magnitude of terabytes and petabytes, huge volumes of data, all the historical data, and it can go back 15, 20 years. Depending on the industry that you're on, there may be regulatory requirements that stipulates how many years of historical data you should keep in that repository. So that data warehouse is critical, but again, it begins a refinement process, but you're not actually at the point where you can present to the executive the information that he needs. The next step is really transforming that data that is in the data warehouse into what we typically refer to as a data mart, which is a structured environment where the data is structured in such a way that it's a lot easier to query and access. Once you move that data into that data mart, then you are beginning to present that data as information. You're making the transition from raw data, atomic data, into information where you've aggregated, you've summarized, you've applied business logic and business rules to that data to begin the process of generating information. And ultimately, once you've defined that data mart and you have that data now stored in the appropriate manner in that data mart, the next step is to leverage the tools that is available to you to present that information to your respective end users. So as you can see, there are different levels of information. The traditional one was the reports, what is typically referred to as our hard copy reports, or, and then we moved into analytics, which is more about scorecarding and know your customer information. We also provided good information from an operational reporting perspective in terms of tell me how did we do for our sales for a particular month, for a particular product. And then ultimately we move into, which is more of the enterprise strategy analysis, which is looking at all of your channels, your touch points, understanding the risk, and then understanding the growth opportunities that exist based on the performance characteristics of your products, your customers, your geographies, and so forth. So this is really what started the whole analytics paradigm. It was really the need to leverage the transactional data stored in the source systems and being able to use that data to provide the information, the critical decisioning needs of your executives. And given that this platform as it stands today is still a critical component of any infrastructure or architecture. So analytics, as we understand it today, analytics is nothing more but really the ability to deduce meaningful information out of that data that I described that existed in the source systems by understanding the patterns of the data points and how they fit together, and given that understanding of how they come together, being able to derive meaningful understandings about your performance, your behavior, things that are likely to occur, things that have occurred that you need to understand why they occurred and mitigate against them happening in the future. So analytics is broad in the sense that it covers three key areas: descriptive, predictive, and prescriptive. So the descriptive analytics is essentially what I just described. It's really looking at your data and understanding what took place, the performance, what took place in the past, last month, last week, yesterday. And you derive that understanding by aligning appropriate data points in such a way. And those data points can be your products, your customers, your geographies, demographics, whatever the appropriate data points. Appropriately linking those data points to understand what transpired over the last month, last week, last quarter, last year. That is still the core component of analytics today. I would say 60 to 65% of business intelligence, business analytics is still focused on descriptive analytics because it's still important. It tells you what has happened, and one can make appropriate decisions to begin addressing ways to mitigate those occurrences, be it fall in sales, be it loss of customers, whatever the derived information out of the description. One can use that understanding to begin taking steps to mitigate against future occurrences. So that's the descriptive. The challenge with descriptive analytics, it really does not prevent you, or it does not help the organization to preempt events, negative events. It just really tells you what has happened. It describes historical events. Companies, as I described in my introduction, are really focused on understanding how they can maintain the competitive advantage, and that advantage can be in very, very, very small amounts, small doses of advantage, and data is really the driving force to helping organizations maintain that competitive advantage. So the shift from descriptive into what we call predictive is critical, because from a predictive standpoint, this is where you leverage the same historical data that you've gathered over the years from your descriptive forum. You begin to apply algorithms to that historical data. You begin to integrate that data with external data sources, be it credit bureau data, be it in the pharmaceutical industry, third-party prescription data. You begin to integrate external data with that historical data, apply algorithms to it, and deriving what we call test and training data categorization. You can more effectively predict both negative events as well as positive events. And companies are finding that to be extremely powerful in terms of the ability to preempt negative events. And what I mean by negative events can be in form of the churn rate, where customers leave your organization. In the case of utilities, it could be the failure of your power grid, transformers blowing up. In the case of healthcare, in the medical industry, it could be understanding what is likely to happen to a customer, to a patient, if those drugs continue to be prescribed to that patient, and understanding that this may likely result in cardio failure or other diseases. So negative events, depending on the industry that you're in, varies quite a bit. In banking, it's really a matter of reducing churn rate in terms of know your customer and making sure that your customers are happy, because in that industry, the cost of acquisition of a customer is extremely high. It's a lot more cost effective to keep the customers you already have as against going out and finding net new customers. So a lot of effort is placed on know your customer, keeping your existing customers and trying to cross-sell to them to expand the portfolio of products that they have that you offer. So prescriptive analytics is all about understanding the likelihood of negative events, and by deriving that understanding, mitigating against those events occurring. And again, leveraging the historical data, applying statistical or mathematical algorithms to that historical data, integrating that historical data with third-party data, external data. And in today's world, that integration of external data takes on a bold new wave, meaning in the past, when we referred to external data, we spoke primarily of structured data. Today, external data, it's a whole lot of unstructured data because of the various avenues that are open to people for communicating with one another, for transacting across the internet. So such things as Twitter accounts, Facebook, and other external avenues or vehicles are extremely important today. And the ability to capture that data and link that with your historical data allows companies to derive very, very powerful information about events, negative events, and the likelihood of positive events as well. So prescriptive is new and growing. It's been heavily utilized in the financial industry, banking, and in the brokerage industry as well, in terms of helping in terms of price fixing and price adjustments. And obviously in the utilities, it's a growing form of analytics in terms of helping utility organizations minimize their maintenance cost. It's a lot cheaper for a utility firm to send out a crew to conduct regular maintenance as against sending out a crew to flip or change an entire set of transformers that have crashed or failed. So from a utilities perspective, predictive analytics is very important in terms of understanding the metering characteristics, understanding the grid characteristics, and being able to track all the communication that occurs across the grid, and making sure that detailed information is fed back into some sort of repository that can be integrated, and applying mathematical algorithms can predict the probability of a transformer or set of transformers failing. So utilities are embracing predictive analytics at a very, very rapid rate. Again, the financial industry, one can say, were the pioneers of it, but utilities and the medical industry as well is embracing predictive analytics quite rapidly as well. So the last pillar in the analytics, the business analytics framework, is what we call prescriptive analytics. As the term implies, prescribe, it's really a means of not only telling you about the probability of a negative event occurring, but also giving you the data points or the things that you need to do to mitigate against those negative events occurring. It's a new and growing area of analytics, but it is being embraced as a critical component of analytics. It's really not just telling me what is likely to happen in terms of a negative event, but helping me understand how I can mitigate against that negative event occurring. That constitutes what we typically refer to as prescriptive analytics.
Hey, Paul. This is Gordon. I'm sorry to interrupt, but we may need to kind of speed up some of these slides so that we can get to the Q&A portion at the end.
Sure.
Okay, thank you.
Right, so the next slide is, again, just trying to show you the transformation that occurs, and I kind of alluded to it initially. We started with data and traditional reporting. Then we moved into what we call information, where one can run queries, ad hoc queries against that data, either from the data warehouse repository that I described or from the data mart structure that I described. Obviously, the data mart structure is more suited for extraction of data into information. The data warehouse is more structured for eliminating redundancy, establishing single version of the truth across the various systems of record that you pull in data out of to populate that data warehouse. And the next aspect of it is knowledge, the ability to derive critical understanding of your operation, what's happening with respect to your products, your customers, what are your competitors doing relative to you, how are you doing relative to the industry standard, and then obviously what really differentiates you. The differentiators is your ability to leverage analytics, predictive, prescriptive analytics, to really understand your customer, to really understand your products, your market landscape, and to be able to make the appropriate decisions in a timely manner, so that you mitigate against negative events and you maintain your competitive advantage. The whole idea is to stay ahead of the fray. So let's focus a little bit more on predictive analytics, because while descriptive analytics is well understood, and also prescriptive analytics is relatively new, predictive analytics has been around for quite a while. So we can spend a few minutes talking about that. So predictive analytics focuses on leveraging statistical models, and there are a number of tools that are available today for helping one write the appropriate algorithms that can provide the insight required. And I'll just mention those tools. It's not on the slide, but I'll just mention some of those tools and the vendors who produce some of those tools. IBM has a product called SPSS. There's a product called R, the letter R. There's also SAS. SAS has a number of modules within the statistical data mining framework. So those are the three, huge vendors out there: SAS, IBM with its SPSS, and R is a relatively new product that leverages a lot more of the big data characteristics that we're not going to have the time to go into. But SAS has been around for a long time, as well as IBM acquired SPSS over the years, I believe about 4 or 5 years ago, and has integrated that statistical package into its overall product offering. When we talk of predictive analytics, we're talking about a number of things. We're talking about segmentation, product segmentation, customer segmentation, optimization models relating to investments, reserves, pricing. Again, that's specific to the financial industry. Also, we can use those predictive analytics for fraud analytics in terms of understanding probability of fraud occurring by looking at a customer or a client's profile, the country he's from, the types of transactions he's been conducting, the balances that he has in his accounts, the addresses that he uses for those accounts, how often, and the volume or the size of the transactions. All of those things, those data points can be put together in mathematical simulation that can allow the bank to predict the possibility of a fraudulent transaction or a fraudulent candidate. Propensity models that speaks to the ability to predict a customer's propensity to acquire a new product through cross-sell, or as well the propensity of a client, a customer to leave, and abandon the relationship. So all of those are really associated with what we call propensity models that allows you to predict. It's all about probability, understanding the probability of a customer to acquire a product if you offer that product to him or her, the probability of a customer conducting in fraudulent activity, the probability of a customer acquiring or growing his account. All of those things are models that clients typically run because they use those models to help them predict growth in terms of revenue, probability of increased revenue. They also use those models to determine losses that they will incur through fraudulent activities or malpractices. So there are a slew of predictive and analytics algorithms that are used by various organizations to determine probability of all types of events occurring. And given the understanding of those probabilities, putting in place measures that can either preempt or mitigate against those events occurring. So executives, as we know today, have been asking real tough questions on how to improve sales, marketing, how to improve on the customer experience while maintaining the appropriate checks and balances that are required to keep the business afloat, keep customers happy, and maintain the growth projections and the revenue stream that exists. So the next slide speaks to 4 key areas: sales, marketing, and customer service, and default management. We know the whole idea with respect to sales is really understanding your customer, understanding your product first, and secondly, understanding your customers. How do you engage your customers? How do you understand them to the point where you know exactly when they're happy, when they're not, and how can you do the right things to make sure that the displeasure does not result in a loss of a customer, and how to deploy the appropriate resources to engage that customer, to turn that customer around so that you don't lose him or her. As I indicated before, losing a customer is very costly because the cost of acquiring a new customer is so high. So clients have, a great desire to keep who they've got, and especially if it's a very competitive environment, a lot of resources are spent on making sure that customers remain happy to the extent possible. And again, a number of tools and avenues are available for one to do that. We do have, as I indicated, relative to 10, 15 years ago, the whole touchpoint framework has changed in the sense that there's so many different communication and touchpoint channels that it requires a much more enterprise and comprehensive solution to make sure that all the data points are brought together in a way that one can derive meaning out of that data. If you look at what we used to call in the past clickstream analysis, which is really looking at when a customer comes to our website, meaning ours in a client's website, understanding every page that they click on, where they came from when they first landed on our page, the things that they looked at on our website, and when they left our website, what's the website that they went to. That's referred to as clickstream analysis, and then taking that clickstream data and being able to integrate that data with your transactional data for that same customer, given an understanding of his demographics, given an understanding of his household income, his or her household income, putting all those pieces together and applying the mathematical algorithms to them allows you to predict levels of satisfaction, and allows you to predict propensities to buy or to cross-sell or to leave. So from a sales perspective, that's critical. From a marketing perspective, it's really the same thing, except there's a slight differentiator with respect to marketing. Marketing has a greater focus on improving the effectiveness of the marketing campaigns. Meaning, a marketing organization has the desire that if it sends out 100 marketing promotion items, the ideal would be to get 100 customers accepting that promotion. But we know that's not reality. It's a very low percentage of prospects who actually turn around and accept an offer. So from a marketing perspective, marketers have a vested interest to limit the number of offers that they send out, meaning they do not necessarily want to send offers out to people that they know are not likely to accept. So the greater their ability to target their prospects more effectively, the more cost effective it is from a marketing cost perspective. So as again sending 10,000 people flyers or promotional items and knowing really that it's a 2% chance or 1% chance of turning those promotions into active accounts, marketers are spending a lot of time focusing on sending out maybe 200 and targeting the 200 people that they know have a higher probability of accepting that offer. And that's where the predictive analytics comes into play, because you can leverage predictive analytics to provide the marketers with the list of existing customers or net new people that are likely to accept a particular product offer based on looking at a number of factors about their behavior, their demographics, where they live, their household, their income, the transactions that they've conducted with you if they're an existing customer, and all that stuff. So from a marketer's perspective, effective campaigning is very important because sending out campaigns are very costly. Marketers have a vested interest to make sure that they can improve on the efficiency of their marketing activities. Again, customer service, similar concept. You want to reduce the amount of time that you spend responding to customers' complaints. So you want to make sure that you can do things that mitigates against a customer having to call a customer service. You want to make sure that you understand what is happening to him or her. So even before the negative event occurs, you can proactively respond to this person or group of people to ensure that you can keep their satisfaction rate at a certain level. So customer service critical in the sense that you want to manage and you want to minimize your time that customers spend interacting with your customer service, because obviously when a customer calls a customer service line, it's 9 out of 10 times it's because they are not happy with something or there's something that they want to do that they're not able to do in an effective way. So you want to minimize that. Again, with respect to banking, default management, you can use analytics to help bankers understand the possibility or the probability of customers defaulting on their loans, mortgages, car loans, whatever. And banks are increasingly becoming proactive in helping customers understand where they're falling short, how they can inform them early in the process to make sure that if there's going to be a shortfall in cash or so forth, that they can take the appropriate steps to mitigate against defaulting on their loans. And also in agreeing to provide a loan to a customer, banks are using predictive analytics as well to provide them probabilities of default by leveraging things such as, and I'm sure you're very familiar with this one, credit score bureaus. Leveraging that, leveraging your transactions, leveraging the relationship this client has with the bank over the years, and putting all that information together and providing what we call a probability for default score that can be used. And again, given that probability for default, if it's a high probability, the bank can adjust the interest rates appropriately to give them some cover. So somebody with a higher probability for default would typically attract a much higher interest rate as against somebody with a much lower probability for default.
Hey, Paul, just a quick time check here. We got about 20 more minutes, and then we do have a few questions that already have come in.
Okay.
All right, thank you.
So the next slide speaks to where we are in terms of the improvement mechanisms and the impact to sales, marketing, and all of that stuff. We know of the traditional inputs from any organization. It could be associated with customer value, social media, third-party data, behavioral data, as I described, in terms of your payment, your channel interactions, your clickstream analysis, your what we typically refer to as our experience with that customer in terms of how long we've known that customer, and also leveraging internal banking data. And again, I'm referring to the banking industry here. And what I mean by internal banking data, those are things such as account balances. It also speaks to a number of the regulatory things that have been applied of late in terms of legal things that have been applied to help banks maintain the appropriate levels of cash liquidity levels, and also help banks better understand to what extent that they have, to what degree they have borrowed, and whether they're approaching the maximum amounts that they can borrow based on the regulatory requirements that have been established. So all of that is critical in as the first set of inputs into understanding the variables that needs to be applied in allowing one to make the appropriate decisions with respect to whether to offer a client or a customer a loan, or whether or not to view a set of transactions from a particular customer as fraudulent transactions, and so on. And obviously, I kind of walk through the outputs. Sales, marketers, and customer service use those things very, very effectively. The marketers are very impressive with how they've leveraged analytics over the years to improve on the efficiency of their targeting. So significant cost reduction has occurred over the years in terms of marketing departments being able to reduce their operating costs by leveraging technology in a much more effective way. So again, we've moved from the traditional, going to the next slide, we moved from what we typically refer to as the traditional business intelligence framework, which was more historical data, slice and dice operations, understand performance, focus on analyzing what happened, and so forth, and moving more into looking forward, predicting things, and trying to stay ahead of your competition, leveraging the power of data, leveraging the power of your ability to derive valuable insights into that data to make the appropriate decisions that can help you mitigate against negative events, reduce your risk by attracting the right customers to your business, reducing the number of customers who are likely to default, or not, I'm sorry, reducing the number of customers who will default based on your ability to use things as probability of default rates and all that stuff, and being able to manage your risk in a very cost-effective way. Those are the things that companies are embracing at a very, very rapid rate today. So why customer analytics? Again, it is the most cutting-edge capability that exists today in terms of helping organizations or clients grow their business. We know over the years that most organizations grew through mergers and acquisition, and there's a serious, over the years, I would say over the last 5 to 6 years, because of the tight economic situation that we were in, a number of organizations were focused primarily on cutting costs and becoming more efficient, becoming more effective at how they do business, and resorted to leveraging the data that they have to be able to determine fantastic or critical insights into their operations. So we do know that when the economy does better, there's a greater likelihood for mergers and acquisitions. when it's a very tight economy, organizations typically, buckle down and try to squeeze blood out of wood, if I can use that phrase. And the ability to get that extra mileage, companies are leveraging analytics, predictive analytics, to help them do that quite effectively. So again, the degree to which companies have embraced analytics varies based on the industry that you're on. I would say again that the financial industry have embraced it over the years. We see a significant growth in that area in the utility companies, especially power companies. And we believe that it's going to be expanded, and the healthcare industry is embracing it, especially with respect to EMR systems, the ability to better understand patient care and better improve on patient care, and being able to provide the appropriate medication based on understanding how patient reacted to previously prescribed drugs, and understanding, given the continued usage of those drugs in combination, that the likelihood of a major event occurring, negative event occurring, is high, and that allows doctors to re-examine patients and make different decisions with respect to the drugs and the types of drugs that should be prescribed to patients. So it is finding a new host in terms of the healthcare industry, and we believe that's going to be a huge growth opportunity area. So from our perspective, from a management consulting perspective, the banking industry has been the traditional user of analytics. They typically have hundreds of data scientists, statisticians, who do nothing but run algorithms, Monte Carlos, regressions, correlations, and all those linear algorithms. And they do that on a day-to-day basis. They typically extract data from huge data warehouses, and typically have their own separate servers and platforms where they do nothing but just run algorithms and run models on data and so forth. What we have done in the last few years is the ability to link the outputs of those algorithms with the appropriate visualization capabilities that can really provide executives with powerful insights into these predictive capabilities. And this is where we're coming in. We're coming in not necessarily with helping clients to write those algorithms. Those have been written, and most clients are very mature in the ability to attract data scientists to help them with that. But the gap and the opportunity for us is the integration with the visualization capability. The Tableaus, the Spotfires, and the other BI tools. How can you help clients take the output from the statistical models that the statisticians have been using over the years, and being able to put this together in a very meaningful way in terms of dashboards and alerts and threshold reporting that can provide them the timely insights that they need, and being able to mitigate against negative events. So from our perspective, the growth opportunity is really being able to understand the various mathematical algorithms that exist, and leveraging standard integration components that exist, and the vendors that have been around for a long time, utilizing those and putting those effectively together into a set of visualization capabilities that clients can truly begin to derive value from the data that they have been creating over the years. So I know it's now 1:45. Gordon, is that a good time?
Yeah. Are you done with the rest of your slides, though?
Yeah, I just want to go over one more slide. I'm just
okay.
mindful of time. Slide 11 is really, I just wanted to take the opportunity to talk about the structure, the infrastructure that is required to support that. So this conversation is primarily about the data. I spoke about the different sources of data, the transformation the data goes through, and ultimately the analytics that is generated out of it. But to support that capability, one requires an infrastructure. You require software, you require hardware, and you require an organization to be able to build that capability. So from a software perspective, I think I mentioned the major players that are in that space from a statistical modeling perspective. We have SAS, we have IBM SPSS, we have R, and then obviously the hardware, there are commodity vendors such as Oracle with the Exadata platform. We have Teradata. There are a number of other vendors who provide in-memory capability, HANA, SAP HANA platforms. We recognize that those algorithms typically run on millions, sometimes billions of rows of data, and some of those records may be hundreds of columns long. So you do need a fair amount of horsepower to be able to effectively run a Monte Carlo model on a 200 billion record database. So you need the appropriate architecture and infrastructure to support the ability to start a model, get to the end, and then do the translation from the output into a probability score that can be consumed as part of a scorecard or a dashboard. So from our perspective, we are looking very closely at that integration component, meaning the outputs of the algorithms, the statistical models, and the data points that needs to be recognized for generating that output, and then being able to take that output and provide visualization using tools such as Tableau, Spotfire, MicroStrategy, and provide powerful visualization. So there's usually a fair amount of investment associated with this, investment in the software, investment in the infrastructure and the architecture. Not to mention now that with the advent of unstructured data, it has become a lot more complex. Whereas this started primarily utilizing structured data, you now have a significant amount of data points that are coming in an unstructured format. And your ability to leverage big data architecture and infrastructure such as Hadoop, and being able to use the right plugins to move from, say, a traditional structured data, which is more row-oriented, to the Hadoop framework, which is more columnar-oriented, more column structures, and being able to understand the mechanics of the Hadoop infrastructure, both from a data node perspective, as well as the communication protocols in terms of the translation points that exist, be it HBase, be it Hive, be it Pig, whatever the different modules, being able to put those together in an infrastructure and architecture design that a client can truly understand and appreciate, and producing the appropriate visualization capability. I think the real money is with the visualization capability, and that's what we want to focus on to be able to really drive the growth. Clients don't care a whole lot, even if they've got a lot of data, unless they can see some visualization. It doesn't translate into much from their perspective. So the visualization component is critical. The ability to show and do it in a very skillful way, to show in the clients how they're doing, what percentage of customers have a high probability for default, what percentage of customers are likely to drop off, and to be able to provide that information in a very timely way is very powerful and very critical. So I'm mindful of time, so I want to leave a few minutes for questions. I think the rest of the slides are pretty straightforward. One can go through them as quickly as possible. Again, I spoke about the probability of default from a customer perspective, probability of acquiring a product, probability of dropping off is also something that we use, and we leverage predictive analytics to provide that understanding. I spoke about segmentation in terms of market segmentation, demographic segmentation, geography segmentation, product segmentation, again. Lifetime value, customer lifetime value, critical components, because as I indicated earlier on, much cheaper to keep a customer as against dropping one and having to go acquire a new one. So customer lifetime value is a critical data point from a predictive analytics perspective. Customer value at risk, again, default rate falls into that category. Fraudulent activity falls into that category, to name a couple. I spoke about transaction fraud likelihood. I won't go through that again. Customer relationship development and optimization. Know your customer. The better you understand your customer by understanding how he transacts, where he goes to, the websites he goes to, what he does on Twitter, what he does on Facebook, the better your understanding of the degree of happiness that this customer has with you as a client, the better your chances to respond to his needs in a more timely fashion and preempt negative events such as a customer leaving or dropping his products. The marketing mix modeling, again, some of those things are more with respect to what we used to call in the past market basket analysis, where you have a number of different products and you want to make sure that given a set of products, you understand how a customer is performing relative to those products. Also, given a customer who has product A, the likelihood of the customer acquiring product B and product C and so forth. So at this point, I am open to questions.
All right, thanks, Paul. We do have a few questions, but if anybody has any last-minute questions, again, please use the questions box and I'll get to them. So the first question for you, is there any one way that is more effective than another with regard to ensuring data is the most current? And is that a feature built in during requirements, or is there a standard industry approach?
That's a very good question. So the data being current, it's all dependent on the solution, the architectural solution that one puts together. Because having the data in itself does not necessarily equate to a smooth or correct solution. It's the timeliness of that data, the ability to get that raw data when it matters and understand what you need to understand out of it in a timely manner is what helps organizations make the right decisions and remain competitive. So, for example, if you have a process of extracting data from your legacy system and it's a nightly batch process, meaning end of day at midnight you run that process to move the data from the systems of record into your data warehouse, then you don't understand what happened yesterday until the next day. And depending on the business that you're in, that understanding, the ability to derive that understanding next day, you may have lost out on a critical opportunity if you have the architecture and the solution that allowed you to move that data in real time. So batch processing has its advantages. It's very good with respect to descriptive analytics, but it tends to fall short with respect to predictive analytics, because the key here is to tell your executives what is happening, what they need to respond to at a much faster rate, and you want to do that in as near real time as possible to minimize the negative effects. So the ability to get that data in real time is what will lead to the data being current. And with the data being current, then it provides you the ability to derive that understanding as soon as possible. Not to mention that there's also the latency, that moving the data into the data warehouse is not the final step, because you now have to apply the algorithms, the statistical algorithms, either from a predictive analytics perspective, to provide the probability scores that you need. Again, depending on the efficiency of your algorithms, how long those algorithms take to execute, that also factors into your ability to draw the right conclusions in a quick time, in as quick time as possible. So that's a very good question.
Great, thanks, Paul. And next question. Can Paul offer some insight based on his experience about the challenges related to adoption across the user base? What are some pitfalls we can avoid to ensure we get the most bang for our buck after implementation?
Well, the thing about user base, it all depends on the degree of relevance to the end user. I think, and what really drives that is making sure that there's clarity from a capabilities perspective. It doesn't help to develop statistical algorithms to provide probability scores on a particular data point that has not been recognized as a critical need from an executive, from a strategic perspective. So the whole idea about formulating probability and predictive analytics output is really about making sure that there's concurrence with the business from a needs perspective. So this should really start with detailed assessment of the capabilities and the shortcomings and the needs, and then you work backwards to truly define the data points and the algorithms that you need to be able to provide the predictions that are required from an executive perspective. So this is truly a top-down, not a bottoms-up approach. You can have a combination approach where you start at the bottom and also start at the top, and the two meet together. But to answer the question from a user adoption perspective, user adoption is a lot more, what's the term? It's a lot more secure if it is done in collaboration with detailed capabilities assessment and requirements gathering that truly provides you from a technology perspective with what the needs are and what the advantages of providing those predictive analytics scorecards are going to provide to that particular business, because it varies depending on the industry that you're in. Also, it varies based on the maturity of the organization, the competitive field that organization is in, and so forth.
Actually, so the next question is kind of similar on that topic. So there are a lot of different BI solutions and capabilities for analytics. Is there a standard approach to implementing, or is it a case-by-case basis with customers? And how do you approach and sell this to clients?
Well, analytics, is broad. There are a number of tools. It depends on what aspect of analytics that you have. If you're focusing on descriptive analytics, then the traditional tools will suffice: the Cognos, the MicroStrategy, the business objects, the crystal reports, and so forth. If you're into predictive analytics, then it's a combination of leveraging statistical outputs, and you obviously the client would typically have had a fair amount of investment done with respect to bringing on statisticians, or if they have not done so, then it's an opportunity for us to come in and help them develop that algorithms, and obviously the tools that we use then, as I mentioned earlier on, the tools such as IBM SPSS, use SAS, and as well as R. Those are the more popular ones that one would use to build the statistical models to derive the predictive outputs. And as I mentioned earlier on, the predictive outputs in itself does not necessarily provide the value to the executive or to the business. What really provides the value is, given that statistical output, that score, that probability score, and linking it to all the other relevant data points about that customer or that product or whatever, and being able to provide the visualization capability that shows that correlation between that probability score and the other characteristics of that customer. That is where the value comes out of, and that is where other visualizations are proven to be a lot more powerful, such as the newer tools such as Tableau and Spotfire. These are tools that are not as robust as, say, a MicroStrategy or Business Objects or Cognos, but they are very powerful in terms of visualization and ideal for executives because of the power of the visual, and they are easily used. I mean, the learning curve for those tools are significantly less compared to tools such as the MicroStrategy, Cognos, and Business Objects, and so forth. So we are agnostic, tool agnostic, and we typically don't necessarily say to clients, you've got to use this tool versus that tool. But then from time to time, we may be placed in the position where clients comes to us and say, we want you to provide us not only the solution architecture and infrastructure, but help us with making recommendations on the tools. And then we go through an elaborate process of scoring and weighing different dimensions of measurement, and we go through that protocol to make sure that we can arrive at the most suitable product or combination of tools that fits the client's needs.
Great. So last question for you, and you may have touched on this already. I know every tool doesn't tackle reporting and analytics equally. Does Paul have any recommendations for tools that do both well?
I missed the first part. Could you repeat the first part of the question?
Sure thing. I know every tool doesn't tackle reporting and analytics equally. Does Paul have any recommendations for tools that do both well?
That's a good point. I think I believe MicroStrategy is a very good product because MicroStrategy, has made some significant advances in terms of its ability to embrace not just the traditional OLAP reporting capability, but has introduced a number of capabilities within the platform itself that allows it to leverage statistical output and provide a more effective and powerful visualization. So that's the one I would mention. Now, I'm saying so guardedly. I don't want to say that the others have not been moving in that direction, but I know MicroStrategy has made that leap quite early on in its evolution. The other visualization tools that I spoke about, the Spotfire and Tableau, those tools are very, very powerful with respect to dashboarding and visualization. So a lot of clients are embracing those tools at a very high rate compared to the traditional BI tools. And again, there are reasons for that. Those are usually a little less pricey than the traditional BI products, and they tend to leverage new technology much more effectively and have much more powerful graphics and so forth. So it all depends on, again, it's not just on the tool. I want to make sure that I make this clear, that a decision to go with a tool may not necessarily because the tool is the better tool amongst the tools that are available, but there may be other consideration that has to be brought to the equation as one goes through the process of determining what's the right tool for this client. Because no two clients are identical. And that is why when you are going through the process of making decisions on tools, you have to go through an elaborate process, documented scores, dimensions of measurement, and the client has to agree to those dimensions and measurements so that at the end of the day, it is not perceived as your decision, but it is perceived to be a decision that was done in collaboration with the client. And it kind of gives you a little bit more cover. Because one of the things that, we make clear to clients is that we're tool agnostic. We have no preference with respect to one versus the other. But we can tell you about our experience using those tools, but ultimately we will not make a decision based purely on our experiences with the tool. We have to factor in your unique characteristics, your environment, your platform, your architecture, the capabilities that you seek. There are a number of variables that needs to be part and parcel of the overall decisioning.
All right. Well,